Okay, now 1 mole of substance, this is the quantity of any substance that is equal to its molecular mass, that is its relative molecular mass. How many particles will be there? These particles can be atoms, molecules, ions, and so on. So this is going to be 6 multiplied by 10 raised to 23 number of particles. This number is known as Avogadro's number. And if this substance is a gas, if it is a gas, then its volume is going to be 22.4 dm cube at STP. STP is standard temperature and pressure, or it will be 24 dm cube at RTP, which is room temperature and pressure. Of course, the pressure of STP and RTP is same. The only difference of this is the temperature. In STP, that is standard temperature and pressure, its temperature will be 0 degrees Celsius. In terms of Kelvin, if you are converting, you have to simply plus, or you have to add 273. So it's going to become 273 K. If the temperature is RTP, room temperature and pressure, these conditions are there, then in that case, okay, its temperature is going to be 25 degrees Celsius. And if it is converted into Kelvin, it will be 25 plus 273 is going to become 293 K. Now the first example that we have taken over here is 1 mole of substance is going to be all of these things. Half mole of a substance, that is half mole of carbon dioxide, CO2. Okay, in terms of decimal also you can write, it will be half will be 0.5 moles of carbon dioxide. We are supposed to calculate, first of all, its molecular mass. Okay, now the formula is CO2. From the periodic table, we are going to get the atomic masses, relative atomic masses. Carbon, the relative atomic mass is 12. This will be provided to you. Plus oxygen, there are 2 atoms of oxygen, so I'm going to multiply this by 2. The atomic mass of oxygen is 16. When I'm going to add this up, 16 into 2 is 32 plus 12. This is 44. 44 is the molecular mass, relative molecular mass of carbon dioxide. That is provided if it is 1 mole. So if it is half mole, okay, instead of 44, we are going to write, it is going to become 22 grams of CO2. Okay, so 1 mole is 44 grams. So half mole will be how much? Simply on cross multiplication, you are going to get 22 grams of CO2.
Carbon dioxide.
Okay. Then in terms of number of molecules of carbon dioxide, for 1 mole it is 6 multiplied by 10 raised to 23. So for half mole, it is going to become 3 multiplied by 10 raised to 23 molecules of CO2. Okay. Now here it is 3 into 10 raised to 23 molecules of CO2. Suppose if I ask you how many carbon atoms are present in this much, it is going to be same. Because 1 molecule of CO2 contains 1 carbon atom.
Yeah.
So these many molecules of CO2 molecules will contain same number of carbon atoms. If I'm going to ask you how many oxygen atoms are present in it, then 1 molecule of CO2 contains 2 atoms of CO2.
Okay.
So these many molecules of CO2, how many oxygen atoms will be present in it? It will be multiplied with 2.
Okay. What into 2, sir?
This number, 3 into 10 raised to 23 multiplied by 2, which is going to give me again 6 into 10 raised to 23 atoms of oxygen. I'm not saying molecules, I'm saying atoms of oxygen. Now, in the same question, suppose if I ask you totally how many atoms are present in half mole of CO2, totally how many atoms are present? 1 molecule of CO2, okay, let's take this part. 1 molecule of CO2 this will be containing 3 atoms total. 1 atom of carbon plus 2 atoms of oxygen. Total number of atoms present will be 3 in one molecule of CO2. So if these many molecules are there, 3 into 10 raised to 23.
Hmm.
This obviously will be multiplied with 3. 3 multiplied by 3 into 10 raised to 23. These many total number of atoms will be present in half mole of CO2.
CO2.
Then the last part, okay, if the temperature is STP, standard temperature and pressure, 1 mole is this many dm cube. Half mole will be half of this, which is going to become 11.2 dm cube
Hmm.
of CO2 at STP.
Okay.
And if it is RTP, room temperature and pressure, it's going to become, okay, 1 mole is 24 dm cube. So half mole is going to become 12 dm cube. This is going to
Yeah.
be at RTP, room temperature and pressure. You can take down these examples, then we are going to do several examples for practice.
Okay.